Question 4e is a one-sided limit. As x goes to 1 from the positive side, we want to evaluate that limit. So again, I'm going to just plug in 1 into that. So I'm going to end up with 2 on top. I plug in 1 on bottom. I'm going to end up with divide by 0. Okay, so since it's from the positive side, I need to know which side it's coming from. It's going to go up to positive infinity or negative infinity. I need to simplify this out. So I'm going to take the limit as x approaches 1 from the positive side. I'm going to simplify this expression because it shares common factors. X plus 1, x minus 1. These are going to cancel out. So then I can evaluate this limit as x approaches 1 from the positive side of 1 over x minus 1. If I plug in numbers from the positive side, I'm plugging in numbers bigger than 1. So I'm going to be approaching 0 from the positive side. Okay, so if I'm dividing by a positive 0, that's going to end up being positive infinity as my limit. Taking a look at g, for g we have a limit at infinity, so this is n-point behavior, and we can use a strong over weak argument. So if we take a look at the highest power, that is x to the power 4 in the numerator, and then we look at the highest power, most powerful part of the denominators, e to the x, we end up having this situation where e to the x is the strongest function. So we have a strong function in the denominator, we have a weaker function in the numerator, and whenever we have this situation, the denominator is going to dominate, so we're going to end up with 1 over infinity, which is 0. And this weak and strong argument works for limits at infinity. It doesn't work for local behavior, so for example, h or j, which we're going to do. We can't use that argument for local behavior, but for endpoint behavior at infinity, we can use this argument. So looking at j, what we want to do is, in this expression, we want to tease out the sine x over x. Okay, so what we can do then is we can use an identity, a trig identity for sine 2x. Well, the trig identity for sine 2x is 2 sine 1x cosine of 1x all over x. And by doing that, we can then isolate a sine x over x part of that limit. So then we end up with the limit as x approaches infinity. Well, we can take that 2 out, so we can take that as times 2 sine x over x. Okay, we know that this limit we can evaluate as 1. And then we have the limit as cosine as x goes to 0 for cosine x. And we can evaluate that limit as well. So we end up with 2 times 1. And then when we evaluate cosine 0 is equal to 1. So we end up the limit is equal to 2. Now, there is a generalization for this, in that if we have the limit as x goes to 0 of sine of some factor a times x over x, this actually works out to be that factor a. I'll write this like this. If we have some factor a multiplying the angle, that limit works out to be a.